X-rays and the electromagnetic spectrum. So what are X-rays? X-rays are the most common form of medical imaging. It's a digital image of the internal composition of the body, which passes through tissue and skin, but not through bone. Dense structures like bone easily absorb X-rays, which is why they appear white. Images produced by X-rays are called radiographs. Radiologists use this to identify problems or diseases. However, too much exposure with X-rays can give you cancer by damaging your normal cells, which is why radiologists sit in a separate room when taking photos. Ionizing radiation from X-rays deposits a large amount of energy into a small area. Enough energy to strip electrons completely away from atoms, thus altering their chemical properties and breaking molecular bonds. In sufficient doses, this can damage and destroy cells. So what is the history behind X-rays? X-rays were invented by physicist Wilhelm Röntgen. Like most inventions, it was invented by accident. Wilhelm was experimenting with electron beams in a gas discharge tube when his fluorescent screen started to glow, even though it was surrounded by black cardboard, which should have blocked radiation. So he decided to put several objects in front of the screen, and he eventually put his hand in front of it and saw a silhouette of his bones on the screen. There are two important parts of an X-ray, the cathode and anode, which sit inside a glass vacuum tube. The cathode is made of a filament with a negative charge, and the anode is made of tungsten with a positive charge. When current passes through the filament, electrons rush to the positive anode. The electrons are moving with force and collide with atoms, which release photons creating an X-ray beam. A camera on the other side of the machine records the X-ray pattern and produces a radiograph. Remember when I said the word photon? Well, when an atom collides with another particle, it excites the atom, causing an electron to jump to a higher energy shell. Photons are related to the electromagnetic spectrum system, but we'll get to that later. Once an electron jumps to a higher energy shell, the electrons will fall back to its original level, which releases light in the form of photons, which then helps to form the image. Now, how are X-rays even related to the electromagnetic spectrum? The EM spectrum is divided into 7 sections, in order of decreasing wavelengths and increasing energy and frequencies. As circled, X-rays have a wavelength of 0.01 to 10 nanometers, which is the second shortest wavelength and second highest frequency. There are two types of X-rays, soft X-rays and hard X-rays. Soft X-rays in range of the EM spectrum is in between UV lights and gamma rays. It has a comparatively high frequency of 10 to the power of 18 Hz. Hertz is equal to 1 cycle per second. It also has a wavelength of 10 nanometers. Hard X-rays occupy the same region of the EM spectrum as gamma rays. The difference between the two is X-rays are produced by accelerating electrons, while gamma rays are produced by atomic nuclei. Hard X-rays have a frequency of 10 to the power of 20 Hz and a wavelength of 0.01 nanometers. The difference between the two X-rays are hard X-rays have a shorter wavelength, are more penetrating, and are produced by high voltage and fast-moving electrons, while soft X-rays have a longer wavelength, are less penetrating, and are produced by low voltage and slow-moving electrons. And that's it. Now enjoy a little parody called All About the Rays.